In this paper we present Synrod, a neuromorphic dataset for synthetic-to-real domain adaptation. When training deep neural networks for event-based cameras, one common issue is data availability, as datasets with a lot of samples and precise annotations are not yet widespread. A common solution to this problem is event simulation, where existing RGB datasets are converted into event streams using an event simulator. However, when the trained system must be used on a real camera, the differences between simulated events and real ones may cause the network performance to decrease on target data. This problem is known as the sim-to-real domain shift, which has been studied in previous works. Another solution is synthetic data generation. In this case, 3D renderers are used to generate synthetic data with precise and free annotations. Nevertheless, synthetic RGB images and real ones usually differ in texture and lighting conditions. These differences may transfer through the event simulation process, resulting in a double shift both in the RGB and event spaces. In this work, we focus on this issue, which we call the synthetic-to-real domain shift, by proposing a dedicated dataset for this analysis. We start from the RGBD object dataset, which is one of the most common object recognition benchmarks in robotics. This dataset also comes with Synrod, an extension adding synthetic data from the same categories as ROD. We extend the first with event recording by moving an event camera in front of an LCD monitor showing real RGB images. We then use the eSIM simulator to extract events from synthetic renderings by performing the same saccadic motion with the virtual camera. The resulting dataset is the first to enable this double shift analysis, which we propose to tackle with domain adaptation techniques. Our network is composed of two main blocks. During training, synthetic events are first converted into a multi-channel voxel grid representation, which is fed through a feature extractor and finally to the main classifier. At the same time, we also take random samples from the target domain and use their features together with those from the source domain within the domain adaptation block. Within this block, features are combined into a regularization loss, which promotes domain invariant features, helping to reduce the gap. We also considered a multimodal extension of this network, making also use of RGB images. We compared the proposed approach against the source-only baseline, which is the performance of the network when trained only on synthetic events and then tested on real ones. We use several well-known domain adaptation techniques and show that all methods consistently improve the network performance on the target domain, with the event modality showing the largest improvement over the other ones. You can follow this link to download the dataset. Thank you.